Hello everyone, this is the Unit 3 review sheet for Algebra 1, and we're going to get right to it because it is pretty long. Topic 1, function or not a function. Which relation is a function? Remember, you just have to look for the x's. We're going to look for the x's repeating, and right there, -1 and -1 repeats, so that is not a function. So we have that -1 right there and that -1 right there, and actually 2, 1, 0, -1, 2. There it is again with the x repeating going to different y's, and that's important. This 2 is attached to -4, and this 2 is attached to +4, and that can't be. So we look at C, and I see right away that 2 repeats going to 2 and 5, and 1 repeats going to 1 and -1. That is not a function, which means D is a function. The only one left, remember 2, 1, 0, -1 and -2, they don't repeat. Every x has its own y. For number 2, which table represents a function that is not a function? I'm sorry, which one is not a function? So we're looking for the x that repeats and goes to different y's, and that is not a function A. Remember, we look at 2, 4, 6, 8. The x doesn't repeat. -2, -1, 0, 1. The x doesn't repeat. I'm not even checking the y's because the x's in B, C, and D do not repeat. A is your answer. Given this relation right here, which value of x would make this relation a function? So that means I cannot pick -3, 5, or -2, because that means the x would repeat and would go to a different y. So -3 is out. There's a -3 already. -1 is not there, so I'm going to pick B. And if I put -1 right in there, that would still remain a function. -2 would mean that this would repeat right here. The -2 is there, and the 5 already is in that. So B is the answer in that relation. Which graph represents a function? Just remember, anytime that you have a graph and they're asking you if it represents a function, you're drawing your vertical line test. Anytime you have that the vertical line goes through 2 or more times, it is not a function. So I just drew 4 vertical lines. The only one that goes through once is the function, and it's A. Remember, every x has to have its own y. So that means the x is repeating here, here, and here with different y's. The x is repeating here and here with different y's, and the x is repeating here and here with different y's. So A is your answer. Which set of ordered pairs x, y is not a function? So we're just going to go through not a function. 3 goes to 1, 3 goes to 2. A is not a function. It's the only one that where the x repeats and goes to different y's. Number 6, answer the questions based on the functions below. Provided below. Create an ordered pair that would make a relation no longer a function. So I am just going to put 1, 3. That means the 1 would be repeating and it would go to a different y. I could also put 2, 5. The 2 would repeat, and I could go to 3, 7. And lastly, I could put down 4, 10. Remember, it doesn't matter if the y repeats. It matters if the x repeats and goes to a different y. So the x can't repeat if it goes to a different y. Remove an ordered pair that would make the relation a function. So I'm going to look at 2, 3, 4, and 3. So I'm going to erase that 4 and the 2. Those are okay, but the 2 pairs of coordinates with 3 and 2 and 3 and 6, I'm going to remove the 3 and 6. And I could put or 3 and 2. All right, number 7, which table represents a function over and over again? 2 and 2, that repeats, goes to different y's. That is not a function. 1 repeats and goes to all different y's. Not a function. -3 repeats and goes to a different y. Not a function. D has to be the answer. -2, 0, 2, and 4. This is the function. Every x has its own y. And then lastly, number 8, which relation is not a function? These are called mapping diagrams. And the mapping diagram, this is your x and this is your y. Remember, the x is the input and the output is the y. So that means anytime that you have 2 lines coming from an x going to 2 different outputs, which is right here, 6 goes to 10 and then 6 goes to 12, that is the one that is not a function. This is your answer. D is your answer because, again, 6 goes to 10 and 6 goes to 12. All right, so topic 2, linear function versus nonlinear function. So we're going to write linear and nonlinear here for the following functions. All of them are functions, so you don't have to worry about that. You just have to worry about if this is linear or not. So this is nonlinear. And remember, you can't have an exponent as the variable as an exponent. For the next one, we have B, that is linear. And it is linear because it is y equals mx plus b format. Has a slope that is constant. This one is nonlinear. The variable cannot be next to the exponent cannot be next to the variable. D is nonlinear. And the reason why is that you can't have the variable in the denominator. And then the last one here, it's linear. This is actually in y equals mx plus b format. All right, and if you did do that division right there, that see this 1 that's there, that slope is -1/3. And the y-intercept is 3. But that slope being a constant slope, that is -1/3. Which of the following sets of coordinates could not be part of a linear function? Let's just check to see which ones are functions. And we're going to 2, 4, 6, 3. So all of them are functions. So all are functions. Now we have to check if it's linear. And I'm just going to go ahead and do this right here. This x is +1. As that x increases 1, the y increases 1. Then the x increases 2. And then the y increases 2. This is linear. Same pattern. So now we have, and I'm going to do this in a different color here, it's 2 to 4. So that's +2. And as that x increases 2, the y also increases by 15. 4 goes to 6, that's +2. 30 goes to 45, that's +15. That's the same pattern, linear. Now we're going to go to the next one, C. 2 goes to 4, that's +2. 4 goes to 6, that's +2. 6 goes to 9, that's +3. 9 goes to 15, that's plus 6. That is nonlinear. Different pattern exists. That means if it's not a constant pattern, that means that it is nonlinear. If you graph this, it would not be a straight line. Right? And that is it for that one right there. All right, which equation below, listed below, is a linear, straight line? Y equals mx plus b. Not that one. Exponent can't be next to the variable. Exponent can't be next to the variable. Y equals mx plus b. C. And exponent can't be next to the variable. C is your linear function. What are 3 characteristics that you can explain when an equation is linear? 3 characteristics that you could explain when an equation is linear. And the equation is in y equals mx plus b format. The graph is of a straight line, and the slope is constant, which means it would be a straight line. And those are 3 characteristics of a linear function. Topic 3. If f of x equals 1/4 x squared minus 1/2 x plus 5, what is the value of f of 6? By the way, if you needed to show work, this is all you would have to do. You would have to put this in 1/4 6 squared minus 1/2 parentheses 1/2 x times 6 plus 5. All right, this answer, basically you're just substituting whatever's inside the parentheses, you're just substituting it in for x. But even so, I'm going to grab my calculator and I'm going to press y equals. All right, very important to press y equals. Alpha x 1/4. I'm going to put this directly in 1/4. And there's your x squared minus, and then parenthesis, you just do exactly what it is this function tells you to do, or it says, and then you x, and then this is plus 5. So let me just check to see if I have the same exact thing. I do. It's 1/4 x squared minus 1/2 x plus 5. Once I have that in, then I can press second function graph, and I could go to where I see an x of 6. So I'm going to grab this, and I'm going to go down. I'm going to go to my x of 6, and there's my x of 6. When x is 6, the y is 1. That means B is your answer. When x is 6, y is 1. You get that right from the calculator. This one, you really don't need the calculator, but h of 4, all right, that's this h of x, right? So I'm going to just do h of 4 equals 2 times 4 minus 10. That's 8 minus 10. H of 4, 8 minus 10 is negative 2. All right, so h of 4 is negative 2. I'm going to put that right underneath there. Plus I of 3. So I of 3 equals 3 squared plus 3. So I of 3 equals 9 plus 3. I of 3 is 12. Why am I making my eyes like that? Basically, that's it. So now we have negative 2 plus 12. Negative 2 plus 12 is 10. And that is the way you do that. All right, at Benny's Cafe, a burger cost let me just highlight this, $4.75. Additional toppings can be added for 25 cents each. Which function can be used to determine the cost, T in dollars, of a burger with T additional toppings? All right. So let's talk about this. The burger cost $4.75. Additional toppings, we don't know how many toppings we're going to get. So we're just going to buy one burger. So which function can be used to determine the cost in dollars of a one burger? So that means that $4.75 is kind of like the y-intercept. It's your initial value. And that 0.25, those are the toppings with T toppings. So it kind of looks like this: 25 cents for each topping plus the $4.75 for the burger. That is 2. 25 cents for each topping, $4.75 for the burger. $4 for the burger? No. 25 cents for the burger? No. I wish. All right, and that's it. All right, if f of x, you really should probably put this into the calculator. I'm going to. Like I said, it's just easier that way to put it into y equals. So I'm going to press alpha x, and I'm going to put 2x on the top plus 6. I'm not going to do anything by hand, leave anything to chance. And then once you have that in, that's this whole function right here. You press second function table, and then let me just see what the x is, -2. We're looking for the x of -2, what the y is when the x is -2. So I'm going to go to -2. The y is 1. And so that means f of -2 equals 1. No work to be shown. If you did show work, if you did have to show work, this would be your work. It's 2 times -2 plus 6 over 2. And that would be -4 plus 6 is 2 over 2. 2 over 2 is 1. So it's kind of easy to do by hand, but also it's easy to do on your calculator as well. Number 5, Gina and Harold work at an electronics store. Gina is paid $225 per week. Gina is paid plus 2% of her total sales in dollars, which can be represented by, and they're nice enough to give you that. So 225 plus the 0.02x, 2% of the total sales. Harold is paid $200 per week plus 2.25 of his total sales, and his equation, his function is right there. Determine the x dollars that they will make their weekly pay the same. Anytime you're talking about weekly pay the same, when you're comparing two companies or two people or two equations, when they're going to cost the same, you always set them equal to each other. So 225 plus the 0.02x equals, you're going to figure out when they cost the same, 200 plus 0.025x. So we're going to get the x's together first, and we're going to minus 0.025x. First, and we're just going to do this, 0.025x. This cancels, and I'm going to grab my calculator, and we're going to get here, let me just clear this graph and clear, 0.02 minus 0.025, and that is 225 minus 0.005 equals 200. So then I am going to subtract 225 from both sides. I'm solving for x, and by the way, I forgot to put the x. This is x right here. Minus 225. So it's negative 0.005x equals negative 25. Then you divide by negative 0.005, and I'm going to use my calculator to get this answer. Negative 25 divided by negative 0.005, and that's 5,000. So the x equals 5,000. So at $5,000 worth of sales, they would make the same weekly pay. Right. I think that is it right there. That was the last one for that. Now we're into topic 4, comparing rate of change. Pretty simple. Just rise over run. What does the rate of change represent? This is not really rate of change. This is just asking what it represents in the context of the problem. So just remember, like, I have to sometimes just put something together like this. Remember, here are the miles. So this is a Honda Civic miles. So we're just going to go 240 minus 60, right? So if I put this together, 240 minus 60, and then 8 minus 2, I would get the number of miles per gallon. All right, number of miles I could go, this Honda Civic goes per gallon. I think I put the words in there just to make sense. The cost of the Honda Civic? No. The cost of each gallon of gas? No. The total number of miles you can travel per gallon of gas. Miles, gallon. Miles, gallon. How many miles a Honda Civic can go on a full tank? No, it has nothing to do with that. C is your answer. Number two, it's supposed to be number 2, is number 1. Benjamin, Layla, and John deposited a set amount of money into the savings accounts. Each month the graph shows Benjamin's. Layla is represented in the table, and John is represented in the equation. For using the information, which statement is true. So we're going to have to figure out the rates of each one of these. So I'm just going to start here with the rise over run. So just going over to 1, and this is 600. Don't put 1 there. M equals 600. So the amount that Benjamin saved per month is 600. That's pretty good. This is x1, this is y1, x2, y2. M equals y2 minus y1 over x2 minus x1. So we got 1800 minus 1400 over 2 minus 1. So M equals 400. Layla saved 400 per month. And so did John, because the rate is right next to the x, that's the slope. M is 400. Using the information above, which statement is true? Layla and John are saving at the same rate. Yes, they are. 400 and 400. A is your answer. John is saving 100 less than Layla. No, they're saving the same amount. Benjamin is saving $500 per month. No, he's saving 600. Layla is saving the greatest amount. No, she's not. Benjamin is. All right. Compare the rates of change of the two functions listed below. So just remember, you don't have to pick the first one. I'm skipping that because I don't want to deal with the negative. So it's y2 minus y1 over x2 minus x1. 6 over 2. That m is 3. The value of y is 3 times. All right, the value of y is an equal sign. 3 times the value of x increased by 6. So the m is 3. They do have the same rate. So A is your answer. And that's it. Kelly created two functions. Which statement is true? I'm going to just go do -2. Rates of change. Okay. So we have x1, y1. x2, y2. We have, I'm just going to put it over here, m equals 7y2 minus y1, which is 7 minus 4, and then 1 minus 0. M equals 3. All right, function A have equal rates of function A and B have equal rates? No, they both, they don't have negative rates. They don't have 0. D is your answer. Function B has the greater rate of change, and that is it. 3 pizzerias. Sam wants to buy pizza for lunch. So the slope, $1, the rate of this slice is $1.25 at Alfonso's. Cheesy pizza is $1.75 per slice. And then Classic Pizzeria is selling one slice for $1.50. You don't even have to do anything to figure that out. You could do x1, y1, x2, y2, but when they have the 1 next to it, you know, everything is to a unit of 1. So when they have that 1 and then the price next to it, that's $1.50 a slice. So which pizzeria charges the least per slice? We're looking at Alfonso's at $1.25. Two functions are represented below. Here we go. What's the difference in rate? So we have 35, and then we have 50. This is rise over run. This is 1. This is 50. M equals 50. Just be careful here. What's the difference in rate of change between function A and function B? Be sure to include the rate of change of each function in your answer. And that's it. Function A has a rate of change of 35, and function B has a rate of change of 50. The difference between the rates of the two functions is 15. And that is what you have to say to get full credit. Number 9, which function has the least rate of change? We're just going to go through right here. And this is 5 and 100. So this is 100 divided by 5. And at the rate is 20 there. This rate is 19. This rate is 40. Just don't forget, 40 per hour. And then this rate, x1, y1, x2, no, wrong. This is a horizontal table. Just be careful there. That's your x2. This is your y1. This is your y2. So the slope would be 1 plus 2, 1 minus a -2, y2 minus y1, over x2 minus x1. So that's 3 over 1. The slope is 3. Which one has the least rate of change? The least. This is 20. This is 19. This is 40. This is 3. Least. All right, topic 5. The table below shows the hours worked last week by managers and office staff for an insurance company of all the employees. So just be careful when you're reading this, of all the employees. So I'm just going to put down all the employees. Okay, wait, I don't have totals. So I need my totals. Right? Okay, so I know it'll be difficult to see, but I am adding up the managers right now. So that's 5 plus 15 plus 8, and that's 28. So this is 28 here. So now I'm going to add up the staff, and this is 35. Make it a little bit bigger. 35 plus 15 plus 8. And that is 58. The total, 58 plus 28, is 86. I'm just going to add down here. This is 30. This is 16. And then that's 40. And this should, when I add these up, it should equal 86. So this is 70, 86. So this 28, 58 is 86. Okay, let's go. Of all the employees, 86 employees. So that means I'm going to make a fraction with the whole on the bottom. That right there, that total on the bottom. What's the approximate relative frequency of office staff who worked less than 30 hours? That's 35 people. So then I grab my calculator again and do 35 divided by 86. And I press enter. So I'm going to get 0.4069. I'm just going to put that down, then I'm going to look at my choices. 40 points. So if I move this over to make it a percentage, that's the one. So 40.7. 40.69 is 40.7, rounds to the nearest tenth. D is your answer. A newspaper conducted a survey to find out how many high school students play video games. To a table below displays the data from the survey. So here's the data from the survey based on the data which is true. There were 2,451 boys surveyed. Yes, there were. That's a check mark. About 19% of them do not play video games. Okay, do not play. All right, so let's go ahead and grab the calculator. And let's see if that percentage is correct. So I'm going to clear this out right here. And I'm going to put do not play video games 858 divided by 2,451. That is 35%. So right there, if you put 858 divided by 2,451, that's about 35%. And that is false. This is out. There were 2,996 girls surveyed. About 65% of them play video games. Let's see. So I'm just going to put 1,361 for the girls that play video games, and then 2,996. Let's see if that comes out. 45% around, this is 65%. So I did 1,361 over 2,996, and I got nowhere near 65%. I got like 45%. So that is false. There were 5,447 students. 46% do not play video games. So out of everyone, those are the numbers right there. 2,493 divided by 5,447. 46%. Yep, true. So that means I'm putting 2,493 divided by 5,447, and that is your answer. No need to check D. All right, number 3 is a lot of questions here. Based on the frequency table, what percentage of students prefer hot dogs? First off, we have to get some totals going. So total and total. So this is 68. This is 74. This is 58. And now I need my calculator. So I'm going to add right across. So 32 plus 44 plus 24, and that's 100. 34 plus 30 plus the 36. That's 100. 200. So females, males. All right, what percent of the students preferred hot dogs? 200 students, and 58 preferred hot dogs altogether. Based on a frequency table, what percent of females preferred cheeseburgers? So just on the females, there were 100 females. How many of them preferred cheeseburgers? 32. And over 100, you know that's 32% if you divide it. What percentage of students preferred cheeseburgers? So all students. So over 200. And cheeseburgers, 68 of them. So 68 over 200. That should be 34. Yes, it is. 34%. Out of everybody, though. Based on the frequency table, what percent of female students preferred hot dogs? All right, female students preferred hot dogs. So 24 out of 100. And that is 24%. And based on the frequency table, what percentage of male students preferred pizza? So we had 100 students. And a 30 out of 100, that's 30%. And that is it. All right, topic number 6. Given the following sequences, which ones are arithmetic sequences? Remember, an arithmetic sequence is either addition or subtraction. If anything has multiplication, that's not an arithmetic sequence. So we're going to just see what the common difference is. This is plus 4. If it does have a common difference, this is plus 4. This is plus 4. This is plus 4. This one is arithmetic sequence. So we're going to put 1 down. So 1 has to be in the answer. Okay, C is out. 2 goes to 20. That's a plus 16. This goes to 100. This goes to 500. Actually, it's multiplying by 5. Multiplying by 5. Not adding, multiplying by 5. That is out. So 2 is out. 3. 2 is out. 2 is out. This is out. This is out. Has to be B. 1 and 3. Let's just check it out. Negative 10 to negative 6 is adding 4. And negative 6 to negative 2 is adding 4. And then same thing, adding 4, common difference, D equals positive 4. D equals positive 4. All right, so B is your answer. In a sequence, the first term is 6 and the common difference is 4. So the first term is 6. So I'm going to put A sub 1 equals 6. Common difference is 4. D equals 4. The sixth term is what? Now, you could figure it out like this, like I'm putting it together right now. Or you could just use the formula. Right? So, but let's just go ahead. And so plus 4 would be 10. And then plus 4 would be 14. Plus 4 is 18. Plus 4 is 22. And plus 4 again would be 26. That is easy enough. I wouldn't even use the formula if it was just me. But if we're using this formula right here, we're going to figure out what A sub 6 is. So A sub 1, they're giving you the first term is 6. The common difference, they're giving it to you is 4. And then you're trying to find out what N with the sixth term is. So the N is 6, 1. Minus 1, according to the formula. So if you put this in to the calculator, you'll get, this is 5, so that's 20. You'll get 26. Yeah, it's a lot of fun. It's a lot of fun. All right, so the first term in the sequence is 3, so a sub 1 is 3. The seventh term is 18. We're going to put it all the way over here. What is the common difference? So we got a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and a sub 7. So we have to make 1, 2, 3, 4, 5, 6 jumps, and somewhere in that 6 jumps, we're going to get to 18, right? So we're figuring, okay, how many actual jumps from 3 do we have to take? 1, 2, 3, 4, 5, and then the 6th one, right? And then 18 to get to 6, to get to 18. We're already given 3. We're given this, but we have to get to 18. But it's 1, 2, 3, 4, 5, 6 jumps. So 18 minus 3. 17, 16, 15. Oh, okay. It's 15. I have 6 jumps, so I'm going to just do 15 divided by 6. And that is 2.5. If that kind of works out. 3 plus 2.5, 4, 5. So it's 5.5. 5.5, 6.5, 7.5, 8. 9, 10, 10.5, 11.5, 12.5, 13, 14, 15, 15.5, 16.5, 17.5, 18. So every jump would be 2.5, adding 2.5. That's really just how I would do it. Figuring out the jumps like that, and that's up 2.5. You're adding 2.5, adding. So the common difference is 2.5. All right, so the sequence is defined recursively as a sub 1 equals negative 5, and a sub n equals negative 2. This is the prior term. Okay, so now if I'm going to start here, this is a sub 1 equals negative 5. Now we're looking for a sub 2. And I'm going to use this formula. Watch, negative 2 times a n a. And then what I'm looking for is n, which is 2, minus 1. Right, that's what it says. Plus 2. Now I'm gonna start to take a look at this. Negative 2 times this, right? This is a 2 minus 1. A sub 2 minus 1 is a sub 1. A sub 1 they're giving you is negative 5. So I'm replacing this. This is a sub 1. And I'm just going to add 2 to it. So negative 2 times negative 5 is 10. 10 plus 2 is 12. So a sub 2 is 12. Now I'm going to go to a sub 3. A sub 3 is negative 2 times a 3 minus 1 plus 2. This is the prior term. Right here. That right there, 3 minus 1 is 2. So I have a sub 3 equals negative 2. A sub 2 is 12 times 12 plus 2. So negative 2 times 12 is negative 24. Negative 24 plus 2 is negative 22. I don't know what that was. A sub 3 equals negative 22. Negative 22. All right. If sequence is defined recursively as a sub 1 equals 2, let's go all the way over here. A sub 1 equals 2. A sub n, which a sub 2, I'm going to go to a sub 2, 3 times, this is the prior term. Okay, so 3 times 2 minus 5. So a sub 2 is 6 minus 5. A sub 6 minus 5 is 1. A sub 3 equals 3 times the prior term, which is 1, minus 5. 3 minus 5 is negative 2. A sub 4 is 3 times negative 2 minus 5. A sub 4 is negative 6 minus 5. And a sub 4 is negative 11. That's it. All right, hope that helped. All right, number 7. This is where we're getting into the graphing. And we're going to graph this on the axis below. So we're going to grab the calculator. Okay, we're going to graph the absolute value of x plus 2. And the easiest way to get to absolute value, remember, is pressing math and then go over to num, and it's right there. And then we're going to just graph x plus 2. And we're going to press graph. So that's what the graph is right there. So we have negative 2, 0. So I'm just going to go to the negative 2, 0, make a point there, and every absolute value is a V shape. So I'm just going to go ahead, and this is kind of like a negative x, and then it stops right there and goes right here. I'm just going to check to see if I have 0, 2 as part of my 0, 2. Yep, that's it right there. This is not piecewise function. This is a full absolute value graph. And now I am going to connect all those points. And I'm going to put y equals the absolute value of x plus 2 on that. So now remember, the absolute value of the parent function is this. So this is what you got there is y is the absolute value of x. This is the parent function. So what happens now? It says to describe, explain how the graph of absolute value of x plus 2 is changed from the graph of the absolute value of x. It just translated or moved 2 to the left. All right, and now we're going to graph the absolute value of x and then plus 3 on the outside of the absolute value. So I'm going to go back here, and I'm going to press math and go to num and go to 1 and put the x in the middle. And I already forgot, that's plus 3. So plus 3 on the outside, then we're going to press graph. And just take a look at it. So this is 1, 2, 3 up. So this is 0, 3. That the point comes to 0, 3. So at 0, 3, which is right here, I'm going to make a point and then just go and make like kind of like graph like that absolute value, that slope of 1. That bothers me. And a slope of -1. It's just in the corner of every box. That's how it goes right there. And the same question they're going to ask. Right here, connect those points. And remember to put arrows just like that. And this is y equals the absolute value of x plus 3. And they're going to say, describe the change from the parent function translated. Three up. And you can put from the origin. F of x equals the absolute value of x, the parent function. So number 3 says the equation to determine the weekly earnings of an employee given by f of x, where x is the number of hours worked. And that gives you this function here with 2 separate parts. This is f of x equals 12x, and then just between these hours, that's what that person makes, and then between anything greater than 35, you would use this function. So it's determine the difference in salary in dollars for an employee worked 40 hours versus 32 hours. So for f of 40, right, this is 40, this is your x, you're going to use this function right here. So we are going to put 14 times 40 minus 20 plus 200. That is way too much to figure out in my head. So I am going to just use my calculator. And I'm going to put that in, 14 times 40 minus, start that again, 40 minus 20, close the parenthesis, plus 200, and that's 480. Let's go ahead and talk about someone who works 32 hours, which is directly kind of like in the middle of this. Not in the middle, obviously, but it's using this function. So f of 32 would be 12 times 32. So 12 times 32 would be 384. And then the difference in salary to answer the question. 480 minus 384 would be $96 difference. And that's it. All right, so it says graph the function. Let me move my face over here. Graph the function absolute value of x minus 3. Now, you kind of remember when we did this in class that if it's inside the parentheses, just remember if it says minus 3, instead of going right, it goes left, right? So I'm thinking it's D. Sorry. I am wrong. Minus 3, you'd think it would go left, but I'm thinking it's going right here. All right. So let me just make sure, but I really think that's the answer. So we're going to just put that, we're going to clear this out. We're going to press math. We're going to press num. We're going to get the 1 right here, and then we're going to put x minus 3 inside the parentheses, which would move it to the right. Right? You would think it would move to the left, but it doesn't. It moves to the right, 3, and A is your answer. Just check it just to make sure in your calculator always, and that's it. So on this one, I kind of made another graph here because it was really giant. So this is called a piecewise function, absolute value and linear function graph together. So we'll do the first one, and we're going to have y equals. We're going to clear this out. We're going to press math and over to the absolute value function. We have x, and we are going to put plus 4, and we're going to put graph. So obviously this moves it up 4. So we're going to 0, 4. We're going to go 1, 2, 3, 4, and we're right here. But we only have to be concerned about the graph between x is greater than or equal to negative 4 and x is less than 2. All right, so I'm going to go here, and here's x of 2. Here's the 2. So I'm going to put an open circle because it is just a less than symbol. And then I'm going to go like this, like this, and that is x of negative 3. Here's x of negative 4, and I'm going to put a closed circle, and then this is my piecewise function that I am showing here. So I'm just going to put f of x equals absolute value of x plus 4, and then x is greater than or equal to negative 4, and x is less than 2. So that's the piecewise function for that. This is linear, so I am going to graph this now. Y equals negative. I'm going to get this out of here. See, negative 4x plus 8, and I'm going to graph it. So obviously this is going down from left to right, and it's crossing at 8. So I put that there. I'm going to move this down here. And I'm going to graph this. This is negative 8 right here. And they just want it at the x is greater than or equal to 2. So it's 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. So this right here is a closed circle. This is where I'm going to start. And then 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And that's about it. So I'm going to erase these. And I am going to, whoa. And I'm gonna that. And so this is f of x equals negative 4x plus 8. And this is the piece of x is greater than or equal to 2. And you can erase the numbers there. I don't like the numbers there. And that is that. All right, topic 8 and the last topic. The graph of the function shown below, use this graph to answer 1 to 3. And I'm going to just put this as a view and zoom in 150. Between which two values is the function nonlinear and decreasing? Nonlinear. So nonlinear and decreasing would be right about here. That is nonlinear and decreasing. So It starts at 4 and ends at 6. And then between which two values is the function linear and increasing? So I am just going to go and put my yellow linear and increasing right there to there. So that's -5 for the x and -3. -5 to -3. And based on the graph, determine the average rate of change from this interval of x is greater than or equal to -3 and x is less than or equal to 1. So we're going from -3 to 1 and including these. So I'm going to erase this. So we're talking about this point here. And let me get back to page width here. All right, so this point right here to this point right here. Those 2 points. So I am going to put, that is -3, 1. And then the other point is 1, 3. And I am going to do x1, y1, x2, y2. Average rate of change. 3 minus 1. 1 plus 4. 1 plus 3. It's 1 minus a -3, but we're just switching it. So it's 2 over 4, and that is 1/2. 0.5. I just moved it down here to show you exactly what I did. All right. Well, okay. All right, based on the graph, determine the average rate of change in dollars per hour over the interval of 2 and x is greater than or equal to 2 and x is less than or equal to 4. So we're going to put these points right here and less than or equal to 4. Right? So again, I'm going to put coordinates down, 2, 60. And then they want to include this here as 4, 100. And then you have your x1, your y1, your x2, your y2. So you have 100 minus 60 over 4 minus 2. That is 40 over 2. And that is 20. Thomas took a 140-mile bus trip to visit his grandparents. His trip is outlined on the graph below. Explain what happened between interval D and E. Okay, the bus stopped for 30 minutes. You could tell right here and explain what might have happened between D and E. The bus stopped for 30 minutes, maybe at a rest stop or something like that, just to take a break, maybe some fuel. People got off. And all that nonsense. So state the interval which the bus traveled the fastest. As I was looking, it almost looked like A to B was kind of like parallel to C to D, but it's not. They're not, those lines. C to D is the steeper line, so that's why that was traveling the fastest during that interval. State how many miles per hour the bus was traveling during that interval. So we're just going to take right now this point and this point right here. So at that point it's 1, 20. And then at this point right here, that is 2.5, 110. So 120, 2.5, 110. Then we're going to do x1, y1, x2, y2. we're going to have m equals 110 minus 20 over 2.5 minus 1. And so we have, we're going to put that calculator up. When I finally got it working, I put 110 minus 20 over 2.5 minus 1, and that is 60 miles per hour. Great. And one more. What is the average rate of speed in miles per hour for Thomas's entire bus trip? Entire. So we're going to start from 0, 0. And we're going to go to the last point, which is F, which is 4, 140. So we're going to do x1, y1, x2, y2. M equals 140 minus 0 and 4 minus 0. So really 140 over 4. Well, let's see how fast we were going. 140 divided by 4. 35 miles an hour for the entire bus trip. And that is it. Hopefully that helped you, and thank you for watching. Bye, everyone.